Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with part 7 or part 8 of the Amstrad PC1512 project. But just before we get on with that, I had a few comments on the previous video about the quality of the video, and it wasn't that good, with this new camera that I've got. I'm not giving up on this camera yet. I've basically, that was the first time I'd messed with that camera, and really I should have spent a little bit of time fiddling about with it and not just trying to record a video with it straight away. What I did find was, I don't know why I missed it when I was actually first looking at the camera, was there was a dirty great big gob of something on the lens, which I'm sure was a lot of the problems that people were seeing. I got some alcohol wipes and I've given the lens a really good clean and managed to get all them little bits off it, so hopefully that'll have made a big improvement. As well as that, I don't know if you can notice, but I've actually improved the lighting in the workshop somewhat. Bit fortunate, someone that I know asked me whether I'd pop down and put them a new kitchen light up. They put some fancy thing from IKEA or wherever. And their old kitchen light was one of those long strips that takes like 4 dichroics that you can adjust, and I thought, perfect. They didn't want it, it was going in the bin. So I've mounted that up on the ceiling of the workshop there, so instead of just having one LED fixture, which I had in the centre there, there's one at the other side of the room there and there's one behind me there, but they're not that bright. I had one really bright one above me and then just a work light that I could move around. I've now got 4 very bright little dichroics, which I can angle, I can adjust, I can get onto the workbench and things like that a lot easier. So hopefully that should improve the video as well somewhat. Anyway, let's get on with actually the projects in hand, which is getting back on with the Amstrad. There's a couple of things I want to do in this video. I really need to get the Amstrad back in its case. Basically, I need workbench space for a rather interesting old radio which has fallen into my possession. So not that I want to completely finish off the Amstrad project just yet, but I really need to get the main board back into the case, drives in it and what have you, and so I can actually power it up and use it. So basically that's what we're going to do today, or at least we're going to do part of that today. First thing we're going to look at though is this is currently only a 512k machine, and it's crying out to be a 640k machine. The board that we pulled out of it, the old board here, if you remember, had been upgraded to 640k. It's got the extra 128k there. What I'm not going to do is pull the 128k off this board and just transfer it straight over onto the new board. Mainly because there's an absolute hodgepodge of RAM there. We've got, sorry, let me just get my glasses on. 1, 2, 3, 4. We've got at least 4 different manufacturers of the DRAM there. We've got different speeds of DRAM. We've got 200 nanoseconds here. We've got some 150s. We've got some which don't actually have even the speed printed on them, and they could even be like 300s. The original 512k there is actually 150 nanosecond, and I believe this should also be 150 nanosecond all the way through. So I have actually just like Blue Peter made one earlier. I went through a lot of my DRAM, and this is all 64k by 1 bit DRAM, all in the different manufacturers, and this is all in different speeds, so we have some 150s and some 200s on here. So we'll go through this basically go through this and we'll select which RAM we're going to use to upgrade the board. So I'll reposition the camera so you can actually see more what we're actually doing here, and we can actually have a look at updating the RAM on this to 640k. So back in a sec. Okay, now I've got you down here, and as you can see, there's the main board. This here's all the RAM, like I said, I've tested. In fact, what I'll do, I will pause the video and I'll just snip in a quick clip showing me just testing a little bit of this DRAM on the iSpeedmaster. It'll also give you a chance to have a look at that EJ/CJ monitor, because I've actually got that connected up to the Toshiba T1000, which I've been using for doing all my DRAM testing. So I'll jump you off here now, and then you'll be back in a sec, and you can have a quick look at that. Right, okay, I'm sure obviously you've seen this in the past. This is basically my DRAM testing setup. What we've got is we've got the iSpeedmaster 1000. This is an EEPROM programmer, like PAL, GAL programmer. It can program all sorts of different stuff. It can also test 7400 series logic ICs. It can test various SRAM and DRAM. It's a very, very, very useful piece of a kit if you're into vintage like 8-bit computers and anything to do with vintage, you know, like digital logic. This thing is brilliant. I've got it connected up to my Toshiba T1000 laptop. You really don't need, I mean, this thing will run on an IBM 5150. You don't need a lot of power. I think you need about 512k of memory or something like that. I'm sure. I don't know if you could get away with 256k. I'm not sure, but you don't need a powerful PC to run this hardware. What I have got, which is slightly different for today, because I've just made my cable up and I want to test it, is instead of running on the inbuilt screen there, or indeed even connected up to this composite green screen, I have actually got it hooked up. Let's see if I can get you on this, to my well, it's actually an EJ monitor. It is CJ backwards compatible, and let me see if I can get you zoomed in a little bit. There we go. Let me see if I can get that a bit squarer. Now, why has that just started to flicker now? There we are. That doesn't look too bad for me filming a for me filming a CRT, does it? Let me perhaps get you. No, like I said, I was a really professional at this, so this would all be done in like pre-shots and everything. That doesn't look too terrible. I know I can see a little bit of like to the image, which is not on the actual screen. In fact, for CGA, I am really, really impressed with the image on that. You just try turning a light off, see if that improves things any. Yeah, let's just try. Does that make that look a little bit easier to see? Hopefully it does. But basically, this is the interface for the iSpeedmaster that I'm using here. Let's get back to the main menu. So basically, this is the software that works with the interface, and what we will do, I'll show you a working one, and then I'll show you a few which are faulty. But essentially, we put a DRAM in the tester, and then we go down to DRAM library there, select that. It actually tells us how to put the DRAM into the tester, that we want pin 1 in the pin 1 of the ZIF socket position. See, basically if you're testing like 74 series logic, you actually put them in the ZIF socket in a slightly different way than if you're testing DRAMs. So we press a key, and then it wants to tell us whether to select a device or test a device. So let's select a device, and it's 64k by 1-bit 16-pin DRAM. That's what we're actually testing, because that's what we need for the Amstrad. So we will select that there, it loads the library file, and we can then literally go test device, press enter. As you can see, it marches a load of ones through the 64K, and the RAM is okay. So that's a good tested DRAM. So that's it there, basically, the one I've just tested. I will just shove a couple in which are actually fails, so you can see some of the ways it will fail. So I'll stick this one in, and we'll do the same thing. It's exactly the same parts. We don't have to select the device again because it's exactly the same. We just hit test device, and you see it's actually failed pretty much straight away. What it expected and what it read back. Device is bad. So I'll shove a couple more in. Let's try this one. And again, same thing. It shows you where it's failed. So we'll do one more. Test the device. Again, same thing. I thought I had one here which failed with a slightly different thing. Let's try this last one here. No, they all seem to be failing the same. Let's try that one. So I thought there was one that had a different failure mode on it. Yeah, there we go. Occasionally when you test them, this is basically what will happen. It'll do the check device position and selection, and like I said, sometimes when the chip is very dead, like that one there, it won't even try and count, it won't even try and march in through the actual RAM. It will literally just come up, it'll actually tell you that you've put the chip in wrong, and that would be the same if you used to have put the chip in upside down. But that was definitely the right way around, so we know that that is a completely bad DRAM. But basically, yeah, it's just a case of going through, and unfortunately, like I said, after that little accident when I was bringing all my stuff down, it's a case of going through a big pot of DRAM like that, digging out all the 64K by 1 bit, then separating it out into the speeds, out into the manufacturers, and then using the Speedmaster like you've just seen to actually test the DRAM and make sure it's okay. By doing that, hopefully we should be able to get up enough to actually repopulate, or at least populate the 2 banks of 64K by 1 bit that we need to actually put the extra 128K into the Amstrad. So we will go back and we will, well, basically I will get back to it once I've finished testing all my DRAM and we have something to install on the board. Okay, did you enjoy that? Like I say, it's a nice little setup that I really like using the Toshiba T1000 like that for an actual proper purpose. Anyway, so this is basically what we've got. That I've gone through all that DRAM, and this is so far what I've actually got tested up. Now I've got a lot of this Mitsubishi. It's M5K 4164 NAP, and this is all 150 nanosecond. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 13 of those. Unfortunately, what I don't have is enough from one manufacturer to do the whole lot of 256K in one. I just don't have enough of the same manufactured RAM. But what we are definitely going to do is this first bank here will use all this Mitsubishi. Get that out of the way. Just straighten a few of those up. And it's just a case of, a lot of this RAM is actually brand new, so it's never been in a board before, so you do sometimes have to just roll the legs in a little bit just to make them easier to get actually in the sockets. just put them on the side like that and just give them a gentle roll just to push the legs in a little bit. And you'll find it's a little bit easier to get them to line up actually in the socket, and then just push them home. There we go, that's one. Yeah, that's a new one as well. I think a lot of this Mitsubishi RAM's brand new. Some of my RAM is salvage, you know, it's reclaimed off scrap boards and what have you, but I do have a fair bit, which, like I said, is like this, which is absolute, it's just new old stock. It's all that came from that closed down computer repair place years ago. It's also the stuff that all went flying when I was bringing it down from my from my other storage space, and I'm slowly going through it all and putting it back so I can actually use it properly. It was a bit of a nightmare, that. Instead of all the boxes I had that could have gone everywhere, it had to be the ones that had all the DRAM in them. Then again, I've also got a hell of a lot of 74 series logic ICs to sort and sift through as well. In you go. I thought that one was going to be a pain. Let's get that back out again. Where's my getting back out again thing? A flat screwdriver. That'll do. If you get one that goes in awkward like that, don't force it, just come back out with it. I should have really bent the legs perhaps a little bit more on that one. Let's try that now. Right, there we go. Let's try that again. There we are, it's gone in this time. Yeah, all this Mitsubishi RAM must be new. It's all the same, it just needs the legs just bending in that little bit to get it in the socket like that. That one went in. I must say it's easiest to upgrade the RAM on the later version of the 1512 because it uses 128K by 4-bit RAM ICs and then just a couple of these for the parity RAM. So it's a lot quicker and easier to do, and it's a lot fewer ICs as well. But I've got two of the older boards here. Right, so which other RAM should we use here? What else have we got that's 150 nanosecond that we've got plenty of? That's all 20 nanosecond. We've got, that's Texas Instrument, this one, I think. I think these are probably used ones, but they are an NMC 36764N 150 nanosecond. I think that's the two little squiggly lines like that. I can't remember who. No, it's not Texas Instrument, that is it? Who is it? Can anyone tell me? I said two little wavy lines like that's the symbol. Anyway, that's who makes them. I could look it up, but they should work absolutely fine. No, that's gone in. hope we've got enough of them. If not, we will have to use one from a different manufacturer, but so I would like to, unless there's any of these on that other board, and we could perhaps just pinch one of them. And remember also you need 9, not 8. Although you know it's an 8-bit bus and the 1-bit chip, so you'd think you need 8 of them. You actually need 9 of them because it uses 1 as a parity check. So it is parity DRAM, this. Is that going in? There we go, that's gone in. Yeah, I'm going to be 1 IC short, so we'll have a quick look over the other board and just see if there's an identical one. We can borrow. If not, we'll have to just find another 150 nanosecond on there. Let's have a look on here. No, we've got none of the same manufacturer on there. So we'll just pick what have we got on here that's 150 nanosecond from a decent manufacturer. They're 200s. Ah, there, we've got a Texas Instrument one there, that'll do. Texas Instrument TMS 4164 150 nanoseconds, that's perfect. So we can, because these are all Texas Instruments chips there. So I'd rather have had, you know, them all the same, but I don't have a full set of Texas Instruments ones. So at least we've got the full set in there now, so that's that upgraded to 640k. The only thing we need to do is tell the main board that it now has 640k, and unfortunately on the Amstrad that's incredibly simple. You've got one jumper here, it's 512 and 640. You just move the jumper across to the 640 position. Now that's the board upgraded to 640k memory. Something else we might as well do while we're here. We won't be able to test it until it's all back together, but like I said, we might as well do it now. Is the old board still has Masco processor on it. Now we know that the CPU off this board works because that's the CPU we're currently running on the other board, so I can't see any reason at all why the Masco processor won't work. So we will carefully take this off the board, being very, very gentle, just using a screwdriver, just to gently lever it up. Now I'm not bothered about the board, I'm not too bothered about scratching the board, but if you were, you'd want to be, you know, you wouldn't want to gash down onto the board like that. So I am being as gentle as I would be if I was wanting to protect the board anyway. There we go, that's free, and that's out there. That's a really nice one. IBM branded 8087. Right, let's get the scrap board out of the way, and he can go into this board. There we go, that's home. And there we are. So that is basically ready to go go back in its case. The issue is now, once we've got it back in its case, is powering the thing up, because at the moment, as you can see, this is basically how I'm powering the board. I've got a Molex connector there, basically what you put on the end of a disk drive, connected up to an old, get you up here a little bit, connected up to an old ATX PSU, which I've got a switch wired up to so I can switch it off and on. And I'm just pinching the 5 volts and the 12 volts from that PSU to power the board up. I'm not powering it up through the original connector there. Yeah, I've been trying to figure out a way to actually do this a little bit better. Now, the board itself will work quite happily just with 5 volts and 12 volts being fed to it. What you will have issues with is some expansion cards, because although basically this entire board runs on just 5 volts and 12 volts, various expansion cards actually need the minus voltages, which we're not currently providing to it. So I've come up with something. It's not an ideal solution. Basically how I can power this board up, provide it with all the voltages that we want. So it'll have its plus 5, plus 12. It'll also have its minus 5 and minus 12, so it'll run with any ISA 8-bit ISA cards we plug in here happily. And it'll also allow us to be able to disconnect and reconnect the power supply, an external power supply, from the main board when we want to fiddle about with stuff. And it won't use basically that incredibly expensive connector on the end there. The reason I'm not using that is that the cheapest I could find an actual DIMM plug to go into the back of it was like £30 odd. I can't justify paying £30 odd for one connector. I find that absolutely ridiculous. I know that they're probably not made anymore and they're hard to come by, and the problem is that it's also shared with the Atari ST. It's the connector that you use for the external disk drive, I believe. Yeah, I think it is the external disk drive on the Atari ST. So I suppose any old stock that was there has been bought up by Atari ST fans for external disk drives and whatnot. I even got to the point that I actually desoldered. That's the connector there, and I actually desoldered that from the scrap, the donor board, my spares board. Because I wanted to see what the pinout underneath was really like and see if I could actually find a different connector I could perhaps put on there that was easier to get. Unfortunately, it's not going to work. So it was worth taking off just to have a quick look. But what I will do is I will clear. In fact, no, I'll show you here now because I've got the basic part of it. What I had. It was a very old RS prototyping board that come with an edge connector along one end. Basically, that like that. And I haven't got all of it. It should be quite a big board like that, and I just had this broken off piece of it. I found it in the bottom of one of my scrap boxes. And basically, so it had a bit more to it than that, and I basically cut it down just to that and had to pair it and file it, and essentially that will now fit into an 8-bit slot like that. Or rather, I think I'll have to just double check this, but the only problem with this is it only has fingers contacts on one side, like I said, usually on an ISA they'd be on both sides. That's not a problem for what we're doing, because on the ISA connector there, all the actual voltages that we're interested in are on that side there. They're on the B side. So providing we have this the right way round, and that goes in the connector like that. Like I said, I've cut this. It was a bit of a faff to do. I had to file it to fit, but I've basically cut it so all them contacts do actually properly line up with the edge connector all the way along like that. And it's quite nice that basically each one of those comes up to a little solder point, We've got some nice strips along, so we've got some grounds there. So what I'm going to do is I'm basically going to make a little interface board that will plug into an ISA slot like that, and it will feed 5 volts and 12 volts down into the ISA. It will also feed minus 12 volts and minus 5 volts down there, and as you know, the ISA bus is all interconnected. One's connected to the other, connected to the other, which will mean that the minus 5, minus 12 will appear on the other two ISA slots, so any cards that I put in there that need those voltages will actually receive those voltages. There's actually very, very, very little that needs the minus 5 volts. There's more that needs the minus 12 volts. But seeing I'm doing it, we might as well actually give it the minus 5 volts as well. I know there's a few sound cards out there that need that minus 5 volts. So basically that's the idea. What I'm going to do. Let's get that out of there. Let's get this out somewhere safe. And what I've decided to use for a power supply is that. It's nice and compact. It's out of an old Dell blade server, so it's got more output than we really need, but that's not a problem. That's not an issue. Essentially, this is pretty perfect. This provides all the voltages we need bar one. And that's the minus 5 volts. This does not produce minus 5 volts. It's got plus 5 volts, plus 12 volts, minus 5 volts, and then like 3.3 volts and all the other modern voltages that we're not really interested in for this project. But what we're going to do is we'll use this to produce, like I said, the minus 5 volts, the minus 12 volts, the plus 12 volts, and the plus 5 volts. And then on this little card here, we will use the minus 12 volts rail to regulate down to produce a minus 5 volt rail as well, using a I've got one kicking about here somewhere, or it's still in the other there we go. That's a salvaged one, but I did actually go out and buy a brand new one, and it has actually arrived before I started making this video, so we can use that one. That's a 7905 voltage regulator. Now we're all familiar and used to the 7805. Basically this is its negative voltage rail cousin. This is designed to regulate down to minus 5 volts rather than plus 5 volts. So we will basically connect that to the minus 12 volt line coming off the power supply and derive a minus 5 volt supply off that. Now it's not going to be high current, but it doesn't need to be. The minus are only really used as like bias voltages for things like op amps in sound cards and stuff like that. You're not going to be pulling serious, your amps through them. We're talking, like perhaps tens of milliamps on the minus 5 volt rail, perhaps a tiny little bit more, on the minus 12 volt rail, but we are talking really small. This should actually tell us what we've got on the minus 12 volt rail. I'm not actually sure. In fact, does this power supply? I hope this power supply has a minus 12 volt rail on it. It should do. We've got 3.3 volts, 12 volts, 5 volts, 12 volts. I will have to just check the pin out on this, but anyway, I will do that. I will just make sure this actually does have a minus. I mean, it won't matter if it doesn't. We could use a bigger power supply. We could use that one because that one definitely does have. I was wanting to use that because it's nice and small. So what I'll do just quickly check and double check that this does definitely have a minus 12 volt rail on it, and then we will come back and we'll modify this power supply and get rid of all the bits we don't need on here, and make it so it's actually going to be usable, because at the moment we've got no way of switching it off or on or things like that. It is going to get a few modifications done to it, and then we will come back and we will look at building this part of it, and then we can actually go about and actually give the thing a test. So back in a sec. Right, well, I'm back, and I've done a bit of research on this, and that's not going to work for us. Good job I did actually check it out, because basically the pinout is exactly the same as standard ATX, apart from the wire there that should be minus 12 volts, that one there is actually plus 12 volts on this power supply. It doesn't give out a minus 5 volts, sorry, a minus 12 volts. So although that is a nice power supply, and will you find a project to use that in, it's not going to work for us for this project. So our other options are what I was using to actually test with, which is the standard ATX power supply. Now that definitely does have minus 12 volts on it. Should say on here, yeah. This has minus 12 volts at 800 milliamps, which is plenty for what we're doing. So we could use that one, although it is a little bit bulky, to be honest. But I had a rummage through my scrap computers, and I found that. Now this is out of another Dell actually, not a server. This is out of one of them little Dell slimline desktops, an old Pentium 4 slimline desktops, them ones with a horrible plastic case. And I mean, it was a scrap computer, major capacitor failure on the main board. That's one of the reasons why I really haven't done anything with it. And they're horrible computers to expand or do anything with. I'd already pinched the RAM and the CPU and various other bits out of it for other projects, but that should do us quite nicely. We'll get this metal work off it. That's the other thing that's horrible about that generation of Dell, was they were designed that you didn't need a screwdriver to do anything. Everything was press tabs and what have you to remove parts from them, and they'd always go wrong, and either it wouldn't latch or it wouldn't come out. They were a pain, them things. I used to have to service these for my previous employer. We had about 15 of them, and they were a pain in the backside, these computers. So they all seemed to start suffering from the capacitor plague. Oh, it's got a loose screw floating around on the bottom of it. Is that meant to be in there or not? I don't like the way that's floating around. Anyway, this should be ideal. This also has its minus 12 volts at only 500 milliamps, but that'll be enough. Like I said, we're talking tens of milliamps for on the minus 5 volt rail, which we're going to create from that. What we can do though is, because this is never going to be used in the actual original computer again, so we can get rid of a lot of this that we don't need. We can pare it down to the wires that we do need, which is that blue one there, which is our minus 12 volts, the green and one of the grounds there, which is our to switch it on. Then we'll need one of the reds and one of the yellows. And that's basically it. That's all we'll need. In fact, we'll probably pinch another yellow. Yeah, we'll take 2 reds, so that's 2 5 volts. We'll take 2 of the 12 volts. We'll take the grounds, like I said, the minus 12 volts there, the switch wires. And we'll pair all this down to just the wires that we need. So let's have a look at getting this power supply open. Screw there. I think that should be it. I think the top should come off now. There we go. Oh, it hinges open, that's nice. Now, can we disconnect that fan? I have to take it off from there. It gives us a chance to give this thing a good clean out as well. There we go. Just separate that off now. Put them over there so I don't lose any of the screws. Right. Now it's a little mucky in here, but it's not too bad. So obviously this is a lot, you know, it's fairly new power supply. Right, what we'll do is we'll get these cable ties off so we can actually manipulate the wires a bit more. That's our green, so that's our power supply on wire. It actually says PS on there, so let's get that freed off. In fact, we could actually fit the switch, couldn't we, onto the that'd look quite neat. We put the power switch for it actually onto the thing here, so we can cut that back, cut that one right back to there. Yeah. Get the rest of this wire out of here. Let's get these out. Now the orange ones are of no real interest to us whatsoever because that's 3.3 volts and we're not interested in 3.3 volts. So all them could be removed. I'm just wondering whether it should be easier to just pull this, I don't know, probably a bit of a mare to actually get the board itself out of this case. We might just cut these off and put some heat shrink over them rather than strip the. We have to take that transformer out there, we have to disconnect that, we have to take that heatsink out. And then we've got one, might be too bad to do. I found out what that screw that was loose there is. That actually holds, yeah, that holds that transformer there in. Right, what I'll do, because otherwise it's going to make this video far too long, I'll just pause the video while I just get this out of the case, and then we can actually look at getting rid of all the wiring that we don't need and just keep what we actually do. So back in a sec. Okay, well that took a little bit longer than I was expecting it to do, but I finally managed to get the thing apart to where it's a little bit easier to work on. And we can start actually getting the wires out that we want. So we want that blue one, we can cut that off there and pull that out. That's our minus 12 volts there. What I'm going to do is I'm actually going to desolder these 3.3 volt wires because we don't need those at all. And we just make a little bit more space if we actually just see if we can get them out of there completely. So let's see if we can just heat that up and pull it out. With any luck. Just get some fresh solder on the end of there, see if we can get it to flow a bit better. There's a fair bit of a thermal mass here, so you do need, let's see there, There we go, that's the first one out. Let's get these other 3.3 volt ones out. Get these out of the way. That's this lot here. That's starting to go now. Just add some fresh solder, see if we can get it to flow a bit more. There we go. We should pull this out soon. It's starting to go. Come on, out you come. Moving now. Just keep the heat on it. This one really does not want to come out. It is coming loose. It's just rather a lot of wires in one connector. Let's see if we can hold it like that and put a bit of tension on it. Perhaps I've done with a slightly bigger iron to get this out. See if it'll go. If not, then we might have to just admit defeat and just cut them off from the other side. And if we cut them off and we make it nice and neat and perhaps add a bit of heat shrink to them, they should be okay. But I was hoping to just... There we go. Eventually it came. See, you've got a huge thermal mass there, that's why it was being a bit of a pain to get out, but basically there we go, that's the 3.3 volt connection gone, so we don't need that at all. I've left a bit of a hole in the board there, but that won't be a problem. Right, so that's a big chunk of what we don't need gone, basically. Just move this back round so we can have a proper look here. Now we've got a lot of 12 volts here that we don't need again. That's purple. That's one that we don't need. That is, where does that go down to there? I think that's another 5 volts, but it's not one that we want. So we don't need that. We can get rid of that. That goes to that point there. I'll have to do something about the come on, out you come. There we go, that's another one gone. I mean, this isn't strictly necessary, but I don't like stray wires that aren't doing anything, just lying around if I can help it. So since we've got the opportunity, I wanted to go in here anyway and just have a good look at the power supply and make sure there was nothing blatantly wrong with it. I mean, this is an older power supply, not, you know, it's a lot newer than the system it's going to be powering. It is still probably, what, 15 years old or something like that, being out of an old Pentium 4. But there's nothing wrong with this at all. I mean, all the caps look healthy, there's no overheating, there's no discoloration, nothing like that. It was, I mean, it was a working supply. It was running in the computer before it was decommissioned. Right, we've got a lot of 12 volts here. This is the yellow wire. Need to get all those together. We don't need all of them. We've got 4 there. Now what we could do, we want 2 basically, so we'll eliminate that one and that one, cut that off there, and this one I'll see if we can pull out because it's basically that one there. again, it's sinking a lot of the heat away from the solder, this, so I might just have to add a little bit of fresh solder. There we go. I don't need that one, I just want them two nice and long. Get rid of that one. So we've got two long ones there, got a couple of grounds there. We don't need that. Those basically, those can go. We'll cut one of those grounds reasonably long because that can be used for the switch, to switch the power supply off and on. That 5 volts there we can get rid of, which is that first one there. That can go. A little bit of fresh solder on there. There we go, that's gone. And the other ground there we can probably cut off. Yeah, we can cut that right off there, that's easy to get to. Snip that off there, and that's one lot of wiring out of the way that we're not going to need. We're going to need those two, we're going to need that. In fact, then 2 grounds are probably going to be enough. Let's have a look here now. Only problem is, like I said, I still do have this basically tethered to there. I didn't want to desolder all that, so it is still a little bit of a mare to faff around with, but it's doable. Right, yeah, that's all that, and that we're happy with. And basically all we're down to now, we've got that grey wire there. Now, I don't think we need that either. That's power supply on. That's the green wire. Now, fortunately, everything is really nicely labelled up on this power supply, so if I scrape a bit of this stuff, it should tell me what this wire actually is. Unfortunately, this goo that they like to stick over everything has completely obscured that. I don't think I'm going to be able to see that. Have a quick look, see if I can scrape it away. We know we don't need it anyway. It says I don't know actually, but I know we don't need it. And we're trying to neaten this up, so let's get rid of it. I'd have to look it up on the ATX pinout. That's indeed if this is full ATX standard, because like I said, this is a Dell power supply, and Dell did sometimes use things slightly differently, as we found out with that server supply. Right, so basically most of that load of grounds there we don't need. We can do away with them. All we need is what we've got there. Again, with the 5 volts, we only really need 2 of these. Suppose we could use 3. No, we only need 2 really. We do only need 2. So let's cut those off about there. Leave a little bit of length from there just in case I do want to use that that connector for something. Get these out. We'll make sure all these are roughly about the same length. So yeah, about there. We'll cut them about there, and then if I need an ATX connector for something, I can reuse that. We'll cut those off there. Those are the two we're going to keep. So those are the grounds that we need. We're going to get rid of the rest of these grounds, and we're going to get rid of them over to 5 volts there. We will just see if we can snip them off right down there and get rid of them. And we don't need any of these grounds because we're happy with those grounds there. We need that one. There are switch wires to switch the power supply on. Let's see if we can get rid of these grounds that we don't need. Again, it's just going to be a case of heating these up and seeing if they'll pull out. We might have the same problem I had with that 3.3 volts. It was rather large and it took a lot of heat to get it out. If not, we'll just cut them off on the board so they are only grounds. I need to kind of prop this up so we can get in there. Let's have a look. Hopefully you lot are not finding this too dull and boring. In fact, that's one great thing with that's why I don't actually mind doing this, and not pausing it or fast forwarding it, because you've got that function with YouTube that if you find bits like this a bit boring, you can just set the YouTube to like double speed and speed through them, which I do find is a nice feature. Of course, or if you'd rather just have this on as like ambient background, you just let it play and watch me fiddle and mess. Come on, are you going to melt? I think that basically that the ground plane there is that big because we've got 3 lots of this all in one. I'm going to do more damage than good just trying to get it out like that. We'll just have a look at just snipping them off. Right, let's get this again in a position where I can see what I'm doing. Yeah, in fact we can just get in there and just cut them off. Maybe we'll do less damage that way. There we go. They're ones we don't need. We'll get them last ones off there that we don't need. Ooh, there we are. That's better. That's what I wanted to do with that one, but that's off completely. Right, we can get rid of that now. And that's more like it. There we are. So there's our minus 12 volts, our plus 12 volts, our plus 5 volts, some grounds, and then those are our switch wires to actually switch the power supply on. So what I will do now, I will get this all reassembled back in the case. I salvaged a little switch. There's another one off one of the control panels off the S4000. I thought that would be ideal, just mounted on this case to actually switch it off and on. So that's what I will do now. I'll quickly get this basically put back together, and then we'll have a look at how we're going to connect this to the actual Amstrad computer. So back in a sec. Right, okay, there. As you can see, I've pretty much got it all back together. That was a bit of a faff to get all that back in the case and not damage anything. But anyway, basically what I've got to do now, I've done is I've drilled a little hole to fit that switch in there. So we'll do this next, and then we can actually get the rest of this all connected up and back together. Let me just get these bits of wire off this switch. Like I said, this is a switch I've just salvaged some out of one of the scrap parts from that electron microscope. So I've still got a couple of bits of old wire on it. Let's get these off, and then we can reuse it. Come on, off you come. There we go, that's one off. Oh, anyone's interested, this power supply, I know it's branded Dell. They're actually made by Lighton. Just as I was putting it back together, I actually just noticed here it's Lighton. So we're not talking cheap muck even on the power supply. Like I said, they're fairly decent, fairly well regarded Lighton power supplies. There we go. I believe these are made by Fujitsu. That's a decent little switch there. So that will basically get that off there. Spin that round so it will go in, and that switch will mount it'll go through the hole, won't it? That's a little bit tight, that. I'm just going to have to elongate that hole. I'll just have to find my step bit and make that hole a little bit bigger so this will fit. I've actually just gone slightly too small on that hole, so back in a sec. Okay, there, I've just made that a little bit wider. Let's try this again. That's it, that'll work nicely. So we'll put the nut on there. Just tighten that down. Make sure I keep that where I want it. I've had to put it in this particular position because it's the only position I could find on this side of the case where it's not going to interfere with anything, because we've got the choke over on that side there, and the fan actually fits in there. So really, there was the only place I could put it. Like I said, where it's not going to actually interfere with anything, and it's as good a place as any for it. It'll be on the front of the power supply, so it'll be easy to get to basically. A couple more turns on that and we should be there. Let's try that. That feels fairly tight. So that's our off and on switch there. All we need to do really is connect the ground up to one point and that green wire up to the other point, and we're good to go. So we'll trim these wires down because they're a little bit on the long side. Trim the ground to say about there. Just hold it with that, and we can use that to strip it like that. And get that. We can tin that wire up. Okay, and then where's my... In fact, we'll do the green one first because that'll be easier. A bit more length on that. You can get it down, go behind there, because we'll want that to go down to about there. Let's cut it to about there. Again, just hold it like that. Twist that up. Tin that up. There we go. bring that down and we'll solder that side in place. There we go. That's on there. And we just got to do the that wire there. Just find a little bit more solder. There's some. Add that to the point first. There we go. Grab this wire. Now we could really put a little bit of heat shrink on the end of these, but they should be absolutely fine. There's nothing that can really touch them where they are. So let's get you in there. Get you soldered down as well. There we go. Let go of that. So that is our, basically that's our off and on switch there now fitted. All we've got to do now is really bring all the wires that we're going to be using out of the case. We'll get them out there. Now I don't like the fact that they've no strain relief on them, so I'm going to just do something about that. Look in my collection of cable ties. Unfortunately there's a nice little hole under here, so we can go through that little hole, up like that, and we'll just put a cable tie on the cables as they come actually out of the power supply, like that. That should be nice and tight, and that'll just stop them being pulled and actually pull in. Yeah, that's going to be absolutely fine like that. Probably is enough room, we could put two on actually, and then we're doubly we're going to be doubly sure, aren't we? There we go. We'll just pull them nice and tight. Fortunately it's got a rounded edge on here, so there's no chance of them wires actually chafing. I just don't want them being yanked too much and actually pulling at the connections in there, so I'm really happy with that now. I can snip off the excess of them. Obviously they're only cable ties, so if we did need to remove them, it's only a case of snipping them. I can still get to the power switch. Now it's literally just a case of putting the putting it all back together. So we'll get the fan back in the top. Put a couple of screws in just to hold it, and then we'll put the other two in when we've actually got the case back together. It'll probably be easier. In fact, I think one might hold it. I'll put another one in. Just put that in there. Right, that's it. That'll hold them in place for now while we actually get the power supply. 'Cause it kind of like hinges. There's some little tabs we need to line up on the bottom. That one's gone in nicely, and then always going the other way. One will go in easy and the other one won't. Get these tabs to line up and go in. There we are. That should clip together. We can put these screws in. Get that out of the way. Put a screw in there. Screw in there. Screw in there. I think there was one. Oh yeah, it's there. There's the other one. Right, we'll look. Oh, and then just put those last two bits in there. They can go in. Okay, and there we go. That's basically the power supply as I want it. So we've got the wires that are going to go off into a connector at the end there, then it'll come out of that connector and into the Amstrad, and we've got a way of switching it off and on there. So that should do as our actual power supply. So what we'll do, I will go and fish out what I'm going to use as the interconnect. So I do want this to be able to be disconnected from the Amstrad obviously when I want to be able to move it about and stuff, and just not have this hanging off the end, or potentially yanking on the interface card I'm going to be putting in there and doing some damage to the main board or the card or something. So I want an easy way of disconnecting that. So we're going to have a look, decide what connector I'm going to use for that, and then we'll have a look at basically putting this all together and giving it a try. So we'll be back very shortly. Right, okay, let's get this part built now. I showed this before. Like I say, it was a piece of a bigger prototype board that already had little gold fingers on it, and I cut it down to fit. I had to file a little notch in that side, so it basically those fingers there line up perfectly when I push it into an ISA slot like that. And that's a good, really nice tight fit. It's just the right thickness. Like I said, I'm pleased with that. That works perfectly. So what we're going to do, let me just get that out of the way for a minute. That's the scrap spares board. I've got a big blown up diagram of the ISA bus here. And essentially what we've got is we've got an A side and a B side, so this being just the 8-bit bus. And basically what we're doing is a piece of card goes in that way. I'll actually put an arrow on the back to show it needs to face that way. On the A side, all we've got are data and address lines really. I/O check, yeah, a couple of I/O checks, and the rest is just data and address lines. We don't need to worry about them for powering up the actual system. So providing we use the fingers onto this side here, what we've got is we've got a ground. We've actually got a reset, so if we wanted to fit a reset switch, there is a way we could do it using this. I won't go into that just yet though. Then we've got plus 5 volts, IOQ which we can ignore, then minus 5 volts, again another IOQ which we can ignore, minus 12 volts, something else we can ignore, and then we've got plus 12 volts, we've got another ground, and then right at the end here we've got another plus 5 volts and another ground. So those are basically what we need to pick up. And we've got everything there apart from that minus 5 volts. So what we're going to do is we're going to pinch that bit of minus 5 volts off the minus 12 volts rail using that 7905 voltage regulator. Like I said, and we're talking tens of milliamps. It's not going to be an issue pulling that off that rail. What I am going to do as well, now I've taken those off the scrap main board, and what I'm going to do is I'm not going to use the actual Molex connectors to power the disk drives on the main motherboard like Amstrad had it set up, for the simple fact that would mean that we're pulling all that current through those edge connectors there. I'll just have those voltages going down onto the board for if they're needed on the board. And the actual disk drives can be fed straight off the power from the power supply we've just made. That's the reason why I put 2 reds, 2 yellows on there, so we can use we can use a plus 5 and a plus 12 and one of the grounds to basically power the disk drives up, and then the other can go down onto the main board. I think that makes life a lot simpler anyway, especially with what we're doing here. Right, let's get this thing made up anyway. So what we need is, well, fortunately that works out really, really well. That basically that edge piece there, the first one, is connected to ground, and that actually connects to this big long ground plane, and that, well, that either it's It's either going to be ground or a voltage plane that's actually made into this piece of strip board, so we can use that's ideal. So what we'll do actually is we'll get all the grounds connected up first, and then we'll work from there. I've got some wire I'm going to use as a hookup wire for all this. That's going to be at the back, so what I want to do is I want to anchor that a bit further down the board really. So in fact this wire is that thick, we might have to drill some of these holes out slightly. Just bear with me a second folks, I'm just going to have to think about this. Right, okay, what I've basically done, I found a drill bit and put it in my little hand drip bit there. It just means I can bring them holes out to large enough that we can easily get the wire through without a problem. Like I said, that's going to be the ground there. So we can now go through, we'll say no problem now, and we can solder these grounds. We'll put the 2 ground wires in place first and then we'll work from there. Right, let's get my iron cleaned off. There we go. First one. That's going to be good and solid, that. What I'm going to do basically is whenever I've got all the wires done is I'll make a couple of holes here and perhaps pass a cable tie through or something just to secure these so they're not going to pull out. Got another of those grounds to go. What have I done with it? There it is. Another of those to put in. Goes through there like that. Solder that in place. There we go. Like that, cool. Right, there we go. So we've got 2 good solid grounds which can go off to the power supply. They should be fine. Now we're going to need, we might as well connect the 5 volts up. And we're going to have one of them get this through there. There, like that. And we'll solder that there just this second, because what I'm going to do is I'm going to take the 2 5 volts from the Molex connectors, and they're going to go in that position. And they can be then fed straight off that power supply, and it's not going to be anything to do with the actual main board. I think that's probably the best solution for this. Now where, what have I just done? Oh, there it is. That's the shorter one. Which should just work out right. Right, now we'll put that in there. This is actually slightly thinner gauge cable, so these do actually pass through the holes in the perf board, unlike what I'm using for the actual main supply cables. I'll just use my pliers to hold that down while I solder this. It won't stay there. Right. See if I can get you down a bit so you can see a bit more what I'm doing. Ooh. Tell you what, the the zoom on this is a little bit touchy compared with my old camera, but it does work at least. Solder that in place. There we go. Just flow that over. That should be good. Let that cool off a sec. There, that'll be fine like that. And we'll just snip them excess. There we go. There we go. That's nice and neat now. Well, I took it off shot there. Sorry. So that's right. Now what do we need? We need 12 volts. Again, we need to basically do exactly the same thing, but with 12 volts. So we'll use a yellow wire. Now I need to make a hole for this, so we'll move over this way a little bit, I think. Yeah, about there. We can space all this out, you see, we've got loads of room on this board for what we're actually doing. Just slightly enlarge that hole. Let's take our wire for 12 volts. That can go in. Oops. Don't want any stragglers when we get this in, it wants to go in nice and smooth. Like that, lovely. That's in. And now, Amstrad didn't use yellow, they used orange for their 12 volts. That can go in that hole there. We want the 12, that one there. Into that hole. Push them home. Just fold that flat there. And we'll see if we can solder that in place the same. Just like we've just done with the 5 volts one. I'll use my pliers just to hold it down while I solder. I mean, I suppose there'd be absolutely nothing stopping someone doing this with a custom PCB, to be honest. I mean, I'm doing this because I just happen to have this bit of perf board with the fingers on it. But if I hadn't have had, I could have just designed something and had one of these PCB manufacturers over in China knock me 10 out. Could probably made something a little bit more elegant actually, but like I said, money's tight. I had this will work, so that's what we're doing. So those are all going to come out the back like that. That's going to work quite nicely. We'll get these last grounds off these soldered in. So we've got, they can go basically anywhere along here, along that ground path I've already started. So put one through there, like that. Put the next one through there. Go on, get in. That one's being awkward. Just give it a tease with the iron. I think it's probably just got a little bit of extra solder on the end somewhere. Let's try that again. Hopefully that one won't pop out while I'm trying to get this one in. That one's being awkward. There we go, let's try that again. Go on, kneel it. If it won't go through, I'll just snip the end off it and yeah, we're not going to keep forcing it like that. We'll just, the amount of material we'll lose, we'll just snip the end off, restrip it. Twist it in. And there we go, it went through the hole, no problem. Right, okay. Let's get those soldered in place. Right, there we go. That's that. I've got 2 more grounds to solder in. From those 2 connectors there, they need to go in. About the same kind of spacing. We'll have to go this way, won't we? Yeah, we'll have to go there. We'll put one in there, and it'll go in. There it is, it's gone in. We'll go next to it with that one. There we go, lovely. We'll solder those final 2 grounds in, and that's all the grounds done. Then we've just got the other wires to solder in, and we're nearly there. There we go. Plenty of solder on them. We'll snip that excess off. Right, so that's our 2 Molex connectors connected up. Now what we do have to do is make sure we keep our wires that go inside the machine and the wires that are going to be coming outside the machine separate, or else we're going to be in a right mess. So let me get all those down that way. That's what we've got connected so far. Those are for inside the machine. So those will go off to the 2 disk drives. And these are going to come out of the machine and connect to the power supply over there. So what we've got else to connect, I've still got some wires here that we've not done anything with yet. And what we need is +5 down on the board, which is that wire there, that connector there, and it is also that connector there. So what we're going to do, I'll strip this off. That will work for that. We're going to need something a little bit thinner though to be able to run between there and over there. So what have I got? Well, it doesn't have to be any thinner, does it? No, it doesn't have to be, I don't suppose. You can just run a piece of that along. Strip that off there. Right. Yeah, what I will do, go to the back there. I'm going to make another hole. I've actually missed a hole out. I'll have to enlarge that hole there as well. There we go. Just them 2 enlarged. is going to be way too long, but it shouldn't matter. No, in fact, let's cut that wire down a bit to make it a bit neater. Yeah. There we go. So that wire is going to be just the right length now. So we'll go from there all the way over let's get that in there. To there, like that. So that connects them two plus 5 volts together. One over there, one over there. We need to get the 5 volts into it, that's that wire there. Now I'm going to need a couple of little link wires. Where is my little box of bits of cut off link wire? Legs there. Right, these should work nicely. Take a leg, and that's the shape, and that can go between there and there. Is what we need just to connect that pin actually to there we go, and we can solder that into place now. Hopefully you can see that. So we'll solder that there, solder that there. Up there. There we go. That's better. Right, okay, that seems to have flowed all around it. Snip off the excess. There we go. And again, we're going to have to just put a little leg between that bit we've just put in there and the actual pin we're going down to. Just double check that is the right one. Yes, third up from the middle. That's exactly the right one. So we're going to just get another reasonably stout spare leg. We don't want like super thin ones. We want something that's reasonable. That'll do. In fact, I know what I could do here. We'd probably make for a bit more of a professional build. I've got some 100 UF 16 volt capacitors here. And what we can do is just put one. I actually got them for use with the 7809, but I've got more than I need for that here, so seeing the 5 volt rail is, you know, fairly critical. It wouldn't help to have a little bit of extra decoupling on it. We can, which is the negative, that's the negative, so we won't go in that way. And the ground rail is right there. There's nothing stopping us just popping that capacitor on there like that. solder the negative side, snip that off, and then we can use that leg, bend it round, and we'll use that on the other side there. Like that, just bend that so it can't come out. Okay, we can solder that in place. There we go. Right, trim that off and make that look a little neater. There we go. So that's the 5 volts down there and the 5 volts down there actually connected up on the board. Which way are we on the board now? Yeah, that'll be okay. That'll come off like that. Then those ones don't want to get mixed up in there because those are for inside. Lovely. That's not too bad. Right, yeah, and that's going to work like that. That'll be happy like that. We're going to put some cable ties and what have you. You can't see what I'm doing. We're actually going to put some cable ties and what have you on here to make these obviously a bit neater and a bit tidier than they are right now. Right, we've only got 2 more to do really. We've got another 12 volts to fit on, which goes down to pin 1, 2, 3, 4, 5, 6, 7, 8, pin 9. So let's get that one put on. And that again is just 12 volts, so that is on, let's see here. Have to make sure I have it all the right way around, or else we're going to make a right mess. So we are on, that's that 5 volts, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So pin 9 there, that's our 12 volts. Unfortunately I have already drilled the hole a little bit larger to fit it in. I'm not actually even 100% sure if there's anything on the actual main board that uses this 12 volts. It might just be for the disk drives and actually for the ISA bus. But obviously we are going to instigate it. Right. Okay, we'll put that little jumper in. Like that. Is there enough? I could technically stick a decoupling capacitor on there as well, you know. In fact, I've got enough, haven't I? These are 16 volt rated, it's a 12 volt rail, so that shouldn't be a problem. Okay. And we'll put that there like that. Oh, yeah, that's right. That's 100% right. We can solder those in place. That really is just like a little bit of extra added decoupling on that line. It's not strictly necessary. I'm sure it's not strictly necessary on that 5 volt line either, but we are coming a fair way from the actual power supply with, you know, just stray wires. It's definitely going to stop any stray AC that's got on there. Any noise on, basically any noise on the DC, it'll just help get rid of it. Like I say, because we have got fairly long wires we're running from the power supply actually into the computer. Let's snip these off. There we go. That's another one done. We've not got that much more to connect up really now, have we? Just make sure we've got all these right. What have we got left to go? So the only thing really we've got left to, because we've got our 12 volts, yep, we've got our 12 and then one there as well, that's one of them. That's our 12 volts and our 5 volts. The only thing we've got missing now is our negative voltages. So I suppose that's what we need to deal with next. So we need to have minus 12 volts going into pin 1, 2, 3, 4, 5, 6. Pin 7 has the minus 12 volts on it. So that is, let's turn this back over again. That's pin 1, 2, 3, 4, 5, 6, that's pin 7 is there. So that is where we want to put our wire, which is going to take our minus 12 volts in. Again, we want to jump that straight back down to where it's needed on the main board. I should do the show. There it is. Not going in very well. Hang on a minute, just tidy this up. Give that another go. There we go, that's better. Yeah, that's in there nice and tight. Put this little jumper in. There we go. We also want to come with a wire off there and further up here because we're going to need that. But we are going to have to jump over one of the grounds to do that, so I'm going to need a little bit of wire to do that with. Now where is my scrap of wire that would do for that? Ah, that's perfect. There we go. You can solder those three in. That one there. That one. The big one. And that last wire I've just added there. Okay, lovely. That's all soldered in. Snip these excess wires off. There we go. Right, so that's our minus 12 volts wire there. We have this extra wire coming off the minus 12 volts, and what that's going to do is going to go to this here, which is our 7905. Now on this, that pin there needs to go to ground. Let's see if it's going to go there. Is it going to fit there? All right. Yeah, that's going to work. We're going to have to fit this a slightly. Bend that down because that's going to go to ground like that. And then where is the output? You have to bear with me a second, folks. I am making this up as I go along. That's our output. Our minus 5 is 1, 2, 3, 4, 5 along. So basically that pin there, right, one, two, three, right, it's that one there. What I was just wondering is if I can get this in such a way that the pin actually lines up where it needs to do, but I think that's wishful thinking. To be fair, I don't think that's going to work, but I think with a bit of judicial bending of these pins I might get something. Just bend that one there. Bends that one about there. Okay, this should work. Yes, that will work. Okay, lovely. Right, let's get this soldered in place and then we can work from it. I might get you just zoomed out a little bit so you're seeing slightly more of what I'm actually doing. Right, so basically I've got the regulator mounted on the board and I've got the... Have I got that right now? No, I've really buggered that up. Yeah, that's not going to work. I've done exactly what I need to do, but in the wrong way round. But hopefully these are going to straighten up again. You can only bend them so many times, obviously, before they start fatiguing. So that one is the one I need to bend shortest, then that one a bit longer, and then that one, which is going to be the ground pin, the longest. That should work. So this is what happens when you, like I said, you just fiddling about and bringing you guys along for the ride, really. Right, that should work. Now we can solder that into place. I had it basically bent so that the output was being grounded, and we was trying to feed the input into the ground. Let's solder that in there. I'll hold it in place. Now that could do with being yeah, beggared up again. Let's get that back out while we can. There we go. What we need is that middle one to be as short as the other one. You'll see why in a minute. I will explain all this too once I've actually done it, but as you can perhaps appreciate, you know, it's quite tricky when you just try and make this up as you go along. Right, let's put that back in now. There we are. Okay, that's better. Right. So essentially we've got the ground now of the 7905 to the ground point. All we need to do is take that wire there and put that to the input, which is the centre pin. Which unfortunately means we have to bend that up slightly so we can get behind it. Cut that wire a bit shorter. So if you was making your own board and spinning your own board, you wouldn't have all this. You'd have it all routed on the board. Obviously, like I said, when I'm just fiddling and faffing about with the bits I've got lying around, we don't have that luxury. Well, it should still work quite nicely anyway. And you just need to connect another wire to that actually while I've got that bent out of the way. I'll use this orange one because I haven't used that wire, that colour yet. Yeah, that should do. And that will go into the output, which is the other side. Go. Bend that back down because I can even hold the wires while we solder them. There we go. And we can get that soldered into place. And then I'm going to have to stop and I'm going to have to throw all this onto the computer because I'm pretty sure that memory card is pretty full now. Unfortunately, this is going to be another of the longer videos, I think. That's soldered in. Lost one there. There we go. I can trim them off. There we go, that's that. And then the last thing I need to do then is take that wire I've just connected, bring that down and connect that to what do we say, pin number 5 over here, sorry, pin number 3, 4, 5, which is that one. Pin number 2, that's 2, 3, 4, 5. It's that one there that we need to connect to. to there, like that. Spin that over. Find a little bit of solder. Seem to have run out of all my bits of solder now. Solder that into place. There we go. And basically, that's it. So what we're going to do, we've got our two Molex connected powered completely independently of the main board of the Amstrad now. They've got their own supply straight off the power supply there. And then we've got the other voltages there. We've got our 12 volts, our 5 volts, our minus 12 volts, and then that board there, which is going to plug into the ISA slot, will provide us our minus 5 volts for the rest of the ISA slots. The only thing I'm going to do now, I'm actually going to go and have something to eat because I'm feeling a little bit hungry. And I'll get all this stuff off this camera so I can get it onto the computer, and then when I get back I'll tidy this up a bit with some cable ties and make it so these wires can't pull. And I've also got a multi-way connector here I found in my bits boxes. Got a couple of these. It's not exactly ideal, but it will mean that I can make an interconnect between, like I said, the power supply and the actual load I've done there. So we'll be back as soon as I've had something to eat, and I'll just knock these little bits up and we can actually test it on the main board and see if this is going to actually going to work. So back in a sec. Right, okay, there we are. That is basically all set back up on the test bench. So we've got, as you can see, we've got the video connected back up. We've got our adapter board plugged into that ISA 8-bit ISA slot there. That is connected through the connector to the power supply at the back there. So if we switch on, that switches the power supply going. If I get you up on the screen, oops, if I can do, there we go, that's better. Just going to get you a bit squarer. But look there. Obviously, I have no drives or anything connected, so it's not going to. In fact, we could just connect a. We could just quickly connect a drive up, I suppose. Let's see if we can get it to boot. I've got, yeah, because I've got a floppy drive here. We can plug that in, and it'll prove that these connectors up here actually are working as they should be. So we'll plug that in there like that. This has fortunately got a boot disc in it. That will go. Is it that way around or is it that way around? I think it's that way around. That will go in there like that. I'll plug a keyboard up as well. So there, as we can get you down. As you can see, we've got floppy drive and everything connected back up. Switch on. So we've actually got a bit of load on the, a little bit of load on it this time. You saw the disk drive there, and if we go up on the screen again, oops, there you can see, and it should, with any luck, there we go, starting MS-DOS. And there we are, that's working nicely. So basically we're at the point now where we can start, put you back down on there. We're basically now at a point where we can actually start putting this computer back together in its case, rebuild it up, and get it back into a working system. We can then like I said, there's other things I want to do with it. I want to see if I can sort the hard drive out one way or another, or I find some alternative to that. And then we can start looking at what software we want to run on this and play about with, and really see what we can do with the machine. So I'm going to leave it there for now for this video, because this has already been quite a long one. Hope if anyone else has got an Amstrad and in the same situation as me, where they've not got the monitor, I hope these videos are going to provide useful for other people, like I said, that can perhaps recreate what I've done, or at least adapt what I've done to their own ends and means. Anyway, so I'm going to leave it there for now. I hope you enjoyed this little update on the project. So thanks for watching, and goodbye. Right, okay, I'm sure you've seen this in the past. This is basically my DRAM testing setup. What we've got is we've got the iSpeedmaster 1000. This is an EEPROM programmer, like PAL, GAL programmer. It can program all sorts of different stuff. It can also test 7400 series logic ICs. It can test various SRAM and DRAM. It's a very, very, very useful piece of a kit if you're into vintage like 8-bit computers and anything to do with vintage, like digital logic. This thing is brilliant. I've got it connected up to my Toshiba T1000 laptop. You really don't need, this thing will run on an IBM 5150. You don't need a lot of power. I think you need about 512k of memory or something like that. I'm sure. I don't know if you could get away with 256k. I'm not sure, but you don't need a powerful PC to run this hardware. What I have got, which is slightly different for today, because I've just made my cable up and I want to test it, is instead of running on the inbuilt screen there, or indeed even connected up to this composite green screen, I have actually got it hooked up. Let's see if I can get you on this, to my well, it's actually an EJ monitor. It is CJ backwards compatible, and let me see if I can get you zoomed in a little bit. There we go. Let me see if I can get that a bit squarer. Now, why has that just started to flicker now? There we are. That doesn't look too bad for me filming a filming a CRT, does it? Let me perhaps get you. Now, like I said, if I was a really professional at this, so this would all be done in like pre-shots and everything. That doesn't look too terrible. I know I can see a little bit of like to the image, which is not on the actual screen. In fact, for CGA, I am really, really impressed with the image on that. You just try turning a light off, see if that improves things any. Yeah, let's just try. Does that make that look a little bit easier to see? Hopefully it does. But basically, this is the interface for the iSpeedmaster that I'm using here. Let's get back to the main menu. So basically, this is the software that works with the interface, and what we will do, I'll show you a working one, and then I'll show you a few which are faulty. But essentially, we put a DRAM in the tester, and then we go down to DRAM library there. Select that. It actually tells us how to put the DRAM into the tester, that we want pin 1 in the pin 1 of the ZIF socket position. See, basically if you're testing like 74 series logic, you actually put them in the ZIF socket in a slightly different way than if you're testing DRAMs. So we press a key, and then it wants to tell us whether to select a device or test a device. So let's select a device, and it's 64k by 1-bit 16 pin DRAM. That's what we're actually testing, because that's what we need for the Amstrad. So we will select that there. It loads the library file, and we can then literally go test device, press enter, As you can see, it marches a load of ones through the 64K, and the RAM is okay. So that's a good tested DRAM. So that's it there, basically, the one I've just tested. I will just shove a couple in which are actually fails, so you can see some of the ways it will fail. So I'll stick this one in, and we'll do the same thing. It's exactly the same part, so we don't have to select the device again because it's exactly the same. We just hit test device, and you see it's actually failed pretty much straight away. What it expected and what it read back. Device is bad. So I'll shove a couple more in. Let's try this one. And again, same thing. It shows you where it's failed. So we'll do one more. Test the device. Again, same thing. I thought I had one here which failed with a slightly different thing. Let's try this last one here. No, they all seem to be failing the same. Let's try that one. So I thought there was one that had a different failure mode on it. Yeah, there we go. Occasionally when you test them, this is basically what will happen. It'll do the check device position and selection, and like I said, sometimes when the chip is very dead, like that one there, it won't even try and count, it won't even try and march in through the actual RAM. It will literally just come up, it'll actually tell you that you've put the chip in wrong, and that would be the same if you used to have put the chip in upside down. But that was definitely the right way around, so we know that that is a completely bad DRAM. But basically, yeah, it's just a case of going through, and unfortunately, like I said, after that little accident when I was bringing all my stuff down, it's a case of going through a big pot of DRAM like that, digging out all the 64K by 1 bit, then separating it out into the speeds, out into the manufacturers, and then using the Speedmaster like you've just seen to actually test the DRAM and make sure it's okay. By doing that, hopefully we should be able to get up enough to actually repopulate, or at least populate the 2 banks of 64K by 1 bit that we need to actually put the extra 128K into the Amstrad. So we will go back and we will, well, basically I will get back to it once I've finished testing all my DRAM and we have something to install on the board.